Hi all, I'm K. Surya working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video, let us see about an important concept which is cloud computing paradigm for IoT data storage. IoT data storage refers to the process of storing the data generated by the IoT devices. So these devices include sensors, smart appliances, wearable devices, and industrial machines. They continuously generate data such as temperature readings, humidity levels, motion detection, logs, system status, and event-based alerts. So this data needs to be stored efficiently for further processing and analysis. So first, we need to understand why cloud storage is needed in IoT. So in real-world applications, IoT devices generate a massive volume of data continuously. For example, say a smart city system may collect the traffic data, pollution levels, and energy consumption data every second. So, storing such huge and continuous data locally is not practical because local storage has limited capacity and scalability. So, additionally, maintaining the local servers can be expensive and inefficient. So, cloud computing solves this problem by providing scalable storage solutions. So, it allows us to store unlimited data and access it from anywhere at any time. So, this makes the cloud storage an ideal choice for IoT applications. So next, we see the mind map of IoT data storage. So here we'll be seeing about the cloud architecture, application protocols, cloud service models, then applications and scenarios and challenges and risks that are faced. So you know there are three types of cloud service models: infrastructure as a service, PaaS, and SaaS. Uh, so apart from this, we have Amazon S3, Oracle database, and Max Cloud NAS. So next, we will see about the cloud computing paradigm uh, for data storage. So data generated by the IoT devices is transmitted to remote cloud servers through the internet. So instead of storing the data locally, it is stored in the cloud, where it can be processed, analyzed, and shared across multiple applications. So this enables real-time monitoring, predictive analytics, and smart decision making. So next is the architecture of IoT data storage. So it consists of multiple layers. So at the first layer, we have IoT devices such as sensors and actuators that collect the data from the environment. The second layer is the gateways, which acts as a interface between the devices and the internet. So it performs tasks like say data filtering and protocol conversion. So next layer is the internet, so which transfers the data to the cloud. So then comes the cloud storage layer where the data is stored in the cloud and managed. Finally, the application layer uses this data for analytics, visualization, and user interaction. So this layered architecture ensures efficient data flow from devices to applications. So next one is the types of data that is stored. So IoT data can be classified into four major types. So the first is the time series data, so which is collected over time, such as say temperature readings recorded every minute. The second one is the structured data, which is organized in the tables like say traditional databases. So the third one is the semi structured data, which includes the formats like XML. And the fourth is the unstructured data, which includes images, videos, and audio data that is generated by the cameras and the microphones. So each type of data requires different storage and processing techniques. So now let us we will see about the cloud storage models. So there are three main cloud storage models. So the first is the object storage. So in this model, data is stored as objects along with the metadata. So it is highly scalable and ideal for IoT applications. The second is the file storage, where data is stored in a hierarchical structure similar to the files and folders. So the third is the block storage, where the data is divided into blocks and stored separately, providing high performance for certain applications. So among these, object storage is most commonly used in IoT due to its flexibility and scalability. So next one is the object storage for IoT. Uh, so in object storage, each piece of data is stored as an object with a unique identifier. So this makes it easy to retrieve and manage the large uh, data sets. So it is highly scalable, meaning it can handle billions of data points generated by the IoT devices. For example, sensor data for a smart agriculture system can be efficiently stored using the object storage. So next one, let us explore the database options for IoT data. So there are three main types of databases used. So relational databases store structured data in tables with rows and columns. However, they may not be usable for large scale IoT data. So in NoSQL databases are more flexible and can handle semi-structured and unstructured data. So they are widely used in IoT applications due to their scalability. Time series databases are specifically designed for handling time-based data. So they are optimized for storing and querying data that changes over time. So now let us understand the time series data storage. So it is indexed based on timestamps. So this makes it highly efficient for storing sensor readings and retrieving historical data. For example, say in weather monitoring systems, temperature and humidity data are recorded continuously uh, and stored as a time series data. So this allows a quick analysis and visualization. So next one is data management in cloud storage. So cloud platforms provide various data management techniques. So data indexing helps in fast retrieval of the data. Data compression reduces the storage space required, and data retention policies define how long the data should be stored before it is getting deleted. And backup and recovery mechanisms ensure that the data is safe and can be restored in case of failures. So these techniques improve the efficiency and reliability of the cloud storage systems. So next one is the security in IoT cloud storage. So it plays a major concern because IoT data may include sensitive information. To protect the data, several measures are used. So data encryption ensures that the data is secure during the transmission and storage. Access control restricts unauthorized users from accessing the data. Authentication verifies the identity of the users and devices, and secure storage policies ensure that the data integrity and confidentiality is achieved. So, implementing these security measures is essential for building trust in the IoT systems. So, next one is the advantages of cloud based IoT storage. So, it offers scalability. cost efficiency, high availability, reliability, and disaster recovery. So hope you understood well. So let us take up some assessment questions. So what does IoT data storage mainly involves? Yes, the answer is storing sensor data, logs and events data generated by the IoT devices. Why is cloud storage preferred over local storage for IoT data? Yes, the answer is IoT generates large and continuous data streams. Thank you for watching this video.